these videos are going to show you how to work some basic gas law problems. The first one, I don't even worry about whether it's Boyles or Charles or Gay-Lussac's or combined. I just start and see what they give me. And so in this case, it's asking me what would be the new pressure if I have 250 centimeters cubed. That's a volume. So we'll call that V1. And it says of a gas at standard pressure. Standard pressure. So I need P1 to be a standard pressure number. So I'm going to go look that up. I'm going to pull out my standard pressures. These are all the same values. They're just different units, kind of like 100 pennies and a dollar. And so when I take a look at this, I see that, oh, I'm going to just choose the easy one. So 1 atmosphere. It tells me it was compressed, so my new volume, V2, is equal to 150 centimeters. And I'm looking for P2, since it's asking me what would be the new pressure. So to work a problem like this, we could plug in and do a gas law. But what's even easier, trying to get rid of my pressure here, is to just look at how the ratios worked. So I know that volume went down. Well, it already told me in the problem it's compressed, and that makes sense because it's getting smaller, because pressure, if volume's down, pressure is up. It's an inverse relationship. So to figure it out, I start with what I'm looking for. I'm looking for a pressure, so I'm going to start with a pressure. And then I'm going to create a fraction out of the things, out of the values that I have 2 units of. So I see that I have 2 volumes. So I'm going to create a fraction out of this so that my result will be higher. So to create a fraction with my result higher, I need to put a bigger number on top. So the 250 centimeters cubed will go on top of the 150 centimeters cubed, causing them to cancel. So I'm going to end up with a pressure, which is what I want. If I multiply 1 times 250 divided by 150, I get 1.67 atmospheres. So this is a Boyle's law problem, a pressure-volume relationship. The next question, again, I don't know what kind of problem it is. It's just thrown at me. But I notice that they give me a milliliter, so I have a V1. It also gives me a temperature, but remember that we have to be okay to be able to work our problems, which means we have to be in Kelvin. Cannot do any gas law problem in Celsius, even if they're asking for Celsius. So when we add that together, the 273 plus the 25, and I know it shouldn't be there, I end up with 298 Kelvin. So then I'm looking for, what am I looking for? It says, what is the volume? So I'm looking for V2. And it gives me another temperature. So it gives me T2, again, doing some 50 degrees Celsius plus my 273. It's going to get me to that Kelvin, which is going to be 323 Kelvin. So now I need to do some thinking. Temperature did what? Temperature went from 298 to 323, so temperature went up. And so we know that if we warm something up, it expands. Gases expand when heated, as long as we're keeping the pressure constant. So the volume can expand. So I know that I'm going to start with my volume, because I want to end up with a volume. And I'm going to pick a fraction, either the 323 on top or the 298 on top. Well, I want to result in a bigger number, so I better put the 323 on top. I'm going to put the 298 on the bottom, and when I work this out, I end up with 162 milliliters. Now, I could have worked this problem using a formula. The formula for Charles' law, which is the volume-temperature relationship, is that volume and temperature are direct, which is a fraction formula. But what's easier to work with is when you move the temperatures to the top. So V1, T2 will move to the other side. V2, T1. So I could have used this formula and solved for V2. Now let's quickly go back to the first one. And we could have solved this one. Now this is a different formula. It's an inverse. Inverse formulas are multiplied. So V1, P1, vice president is what I call it, is equal to vice president, V2, P2. This case, it's already in a straight line, so I could have just solved, oops, wrong one. I could have just solved for P2. So V2, P2, solving for P2, moving V2 to the other side. So those are examples of a Charles law and a Boyles law.